हेलो स्टूडेंट्स, वेलकम टू gulshantutorials। आज हम पढ़ने वाले हैं इलेक्ट्रोमैग्नेटिक इंडक्शन एंड इन दिस टॉपिक वी आर गोइंग टू स्टडी Faraday's law and Lenz's law। So to understand this topic completely, kindly watch the video till the end and don't skip. Okay, so first let's begin with Faraday's law. What is Faraday's law? There is a story behind it. Like once Faraday was doing several experiments, he made a loop. This is a loop, means circular loop. It is of metallic thing. He passed several objects through this loop and he connected an ammeter. Ammeter, as you know, it is or galvanometer we can say. These are the devices which are used to measure current. Okay, to measure current in the circuit. And you can see this is a complete circuit like this, and it is ammeter. Okay. So he passed several objects, but there was no change in the ammeter reading. But when he brought the magnet close to this, then the needle deflected. Okay. So due to this magnetic field or this magnet, when it was brought closer to this loop, the ammeter means the current reading was increased or decreased. It shows. It means there is something related to magnetic field and this loop. So as he did many researches, then he came to a final conclusion. Okay, what was that? Whenever the flux of magnetic field through the area bounded by closed loop changes, then an EMF is produced in the loop. Means whenever any magnetic flux means when a magnet is brought, then there will be magnetic field lines, and magnetic field lines in wholesale they are called as flux. In a particular area we can say flux. When that flux or means magnetic lines, they are passing through this loop. This is circular loop, rectangular loop, but it should be closed. They are passing through inside this closed loop area. Okay, when this magnetic field are passing through this closed loop area, then the EMF will be induced. Okay, now what is this EMF? EMF is electromotive force. It is not any force or it is not any voltage like thing. Unit is voltage. Okay, that is acceptable. But it is a force. It is a force which is generated inside this loop or because of this loop to oppose this magnetic field. Okay, so this electromotive force, it can be denoted mathematically as minus d phi by dt. So it was not because of the flux, it was because of the changing flux. This is the very important point in Faraday's law. When the magnetic field is changed, magnet should be brought and then taken back. It should be brought closer and then again back. Things like this should be done with this magnet. Okay, what is happening when it is bringing closer? Like when the magnet is brought closer to this loop, the magnetic field will be maximum. Okay, and when the magnet is taken away, like it is very far from this loop, then the magnetic field lines will be less inside this loop. Okay, means the magnetic flux will be less. So when there is flux changing or change in flux, then only the EMF will be induced. But if we kept this constant, if we brought this close to here and then the flux is kept constant, then there will be zero EMF. Okay, zero EMF. EMF symbol is EMF, or you can say like this also. Okay, EMF is minus d phi by dt. Minus d phi by dt means change in flux per unit time, or we can say it is minus delta phi by delta t. Delta means change in, or we can say this is the average flux change. Average flux change throughout this period, and this is instantaneous change in flux. Okay, so d minus d phi by dt or delta phi by dt. What is this phi? Phi is magnetic flux. Okay, phi हो गया magnetic flux inside the loop. इस loop के अंदर जितना magnetic flux है, that we are saying as magnetic flux inside the loop. It is denoted by phi symbol. Its unit, or we can say SI unit, is Weber. Weber we can say WEBBER, Weber or Tesla meter square. Okay, Tesla meter square. And we can find out this magnetic flux by using this formula: magnetic field density into area, means the density of magnetic field at a particular point B and multiplied by the that area through which we need to find the magnetic flux. Okay, integral of B dot ds. Now we can say area integral of magnetic flux. Okay, then we can determine phi. Phi is magnetic flux. So the change in this phi means change in this magnetic field. A magnetic flux will give us EMF, resulting EMF across this loop. Okay, this was the statement, this was B. Now if we substitute this value here, then what we get is minus of, or this we will do in the Lenz's law. Okay, but let me tell you, what does this minus indicate? This minus sign indicates that the EMF induced inside this loop will oppose the cause. Means जिसकी वजह से EMF प्रोड्यूस हुआ इसके अंदर, वो अपने आप को प्रोड्यूस, वो खुद ही मतलब उसको अपोज करेगा. It will oppose the cause. Cause means this magnet. It will oppose this magnet, or it will apply against force on this magnet. Okay, so that this flux should not be passed into the loop. I hope you understand. This is the EMF. EMF is minus n d phi by dt. For 1 turn it is minus d phi by dt. But if there are n number of loops, n number of turns, then it is minus n into d phi by dt. Right? And there is a, using Ohm's law, we can say current is equals to voltage by resistance. If the resistance in this loop, or we can say resistance is connected in this loop in series, then current can be written as minus n d phi by dt divided by R. EMF divided by resistance will give us current in amperes. The unit of EMF is volts, obviously, because it is a voltage quantity. But physically the meaning is not related to voltage. Okay, it is mechanical meaning. It is electromotive force. Right? So this was the concept given by Faraday's. This you can write for 5 marks question and you will get absolutely 5 marks. Okay, but be careful while writing the units. Okay, I hope you understand. Is there any doubt? Then you can ask me. Right? In the next concept, now I will explain in the next video about Lenz's law. Okay, what is Lenz's law? What are the states? Okay, so in this video, let's come to end. And thank you for watching my video. And if you like my video, then please subscribe and share with your friends. Thanks a lot.